Here we can see how a basic solar cell works using the PN junction semiconductors. So this one up here has more positive holes. You can see here the positive holes, and when you put a negative N-type semiconductor next to it at the boundary, at the junction here, the negative type jump into the positive holes and they remove any charge carriers from here. So there's, in the center here, there's no positive holes or negative charge carriers, electrons. They've been taken out of action, essentially. So we can see what happens. That depletion zone in the center there, where the positive holes and negative electrons from the negative N-type and P-type. Okay, remember these ones have atoms, they're doped with atoms from the group 3, so phosphorus and those sort of things. These are the N-type, and they're doped from group 5. So there's a depletion zone there. When the solar radiation strikes, there's enough energy for electrons and photoelectrons to form. Those photoelectrons and electrons can move across that energy gap into the P-type. Extra electrons move around rather than so once there's an extra electrons in this layer, they move around, then come back the positive holes where the electrons left. So if there was an electron here, it left and went up here, left a positive hole, so that positive hole moved down here. So these electrons, when they become excess up here, will go around the circuit through the motor or the light or whatever it is you're running with your solar cell into the N-type layer to replenish the electrons of the N-type layer. And that's basically how a solar cell works. Very simple. It requires putting a P and N-type together. The depletion layer allows, once enough energy is gained, electrons can move into the P-type layer and positive holes can move into the N-type layer past that boundary. The electrons that move up into the P-type can then go around the circuit back to where they came from, and that movement back is enough to power something like a motor or a light.